In our previous video, I said that streams are very different than collections. Now is the time, let's discuss about how streams and collections are different. So we have few pointers to discuss around that. First is data representation. Now how the data within a collection is represented versus how the data is present in the streams. So in collections are nothing but a group of objects, right? But these objects are stored within an underlying data structure. Now this data structure could be an array, a linked list, a tree or something, right? But in case of streams, there is just an abstraction layer on top of the source data source, and then the processing is done. Okay. Now in case of collections, these elements can be modified. We can add an element to the collection, we can remove, we can update, right? But in case of string, since the streams do not contain the elements itself, rather they are with the original source. And this source could be what? It could be a collection, it could be an array, it could be in any file like, IO input like file, right? So basically streams are just an abstraction layer. So, and they do not modify the source data, right? They do not modify the source data. Second is eager versus lazy evaluation. Now collections are eager in nature. What is the meaning of that? The meaning is they eagerly compute and store the elements. Okay. And the disadvantage goes, because of the eager processing is when we have large data set, for every step it is going to process them and then it is going to pass to the next step. Whereas in case of stream, we already discussed that intermediate operations are all lazily evaluated unless there is a terminal operation. These all intermediate operations will not be executed, and that helps in our advantage when we have a large data set to process. Okay. Third is mutability. Now we already said that collections can be modified. We can add element, remove element, we can update the collection elements, right? Streams cannot be. Streams cannot be modified. So streams are immutable. Remember that streams are immutable because they do not modify the underlying data source, right? Fourth, sequential versus parallel processing. Now, in case of collection, there is no inherent support for parallel processing. So in order to achieve parallel processing in case of collections, what we can do is we can take help from multi-threading. So we can create multiple threads and we can pass on the collection object and we can process the elements. But in case of streams, there is a parallel stream. There is something called as parallel stream, which we are going to discuss in detail in upcoming videos. Okay. So parallel streams are nothing but they just divide the data into a smaller chunk and then process them concurrently, concurrently they process. And that's how, we are able to achieve optimum utilization of CPU, right? And this is very much supported and widely used. When we have large data set to process, then we go for parallel processing. Okay, we are going to see examples. We are going to compare when to use sequential stream, when to use parallel stream. We are going to write a program and see how performance is better in case of parallel stream when we have large processing to do. Last one is declarative versus imperative style. Now, when working with collections, we typically use loops, other statements to manipulate and process the data. Now, it becomes little bit lengthy to write our code and do the same thing, which in case of stream, we use a declarative and functional program style of coding, like we use lambdas, we use for each method, and there are other methods like map, filter, reduce that make our code very concise and readable. And we are able to write we are able to do a lot of things, lot of work within few lines of code. Okay, so these are some important differences between streams and collections to keep in mind.